Okay. So now, I mean, y'all can be heard too because we're recording. So if you say something stupid, keep in mind like it's on video. Do you recognize this from chapter 10?
Yes.
Yeah.
This was our little moleville map about how you could go from moles to grams, moles to liters, moles to particles. We should already know how to do this. This is old news. What we're adding to it now is that we can go from moles of what I'm calling A, which is just some substance, whatever. We can now go to moles of something else. Now if I cover up this one, is this the same thing?
Yeah.
It's still moleville. Like same idea, I can go from moles to grams, liters, and particles. What we're tying in now that's different is that we can go from moles of one thing to moles of something else. Okay? This is exactly like what we did before, with the twist of how to get from substance 1 to substance 2, or substance A to substance B. Let me show you a couple of examples of what this looks like to get a feel for it, and I'll give you some tips and tricks. Right here, I have two conversion factors. If you look at them, it's moles of A over moles of B, or moles of B over moles of A. These right here are called mole ratios. You getting this? A mole ratio is simply moles of one thing over moles of something else. Okay? I'm going to pause the video for a second and Alright, I've added some stuff to the bottom now. So I have some tips for you about how this is going to work. It says right here, in order to do a mole ratio problem, you have to have a balanced equation. And I'll show you why in just a minute. Number 2 says the number 1 will go with the word mole in every conversion factor except the mole ratio. Number 3, the goal of every problem is to get to moles at some point. Wasn't that the same thing last time? They're called mole problems, so therefore, I mean, you got to get to moles somewhere along the way. Goes with, okay, I'll pause here again so that the class can write this down, and if you're watching from home, you pause too and write it down. Alright, I have a sample problem down here at the bottom. It says, here's our equation that we're going to have to do this, and you'll see why. 2H2 plus O2 yields 2H2O, and you have this right here that says how many molecules of oxygen are needed to make 36.1 grams of H2O. So, you can pause for a second and write it down. Alright, so a couple of things about this equation right here. Alright? We can use this equation kind of in the following manner. We can look at this equation and we can think of it in terms of moles. If we think of the coefficients as the number of moles, we could read this equation as 2 moles of hydrogen plus how many moles of oxygen? 1. There's an understood 1 there, yields 2 moles of H2O. And that would be perfectly true. If I draw it out for you, in terms of like molecules, if this is H2 bonded together, what this is 2 of them, right? Like 2 molecules of H2. And then we've got how many molecules of oxygen? 1. And then over here on this side, we will have 1 molecule of H2O and actually another molecule of H2O because it says that there's 2 of those. It also works to say that there's molecules. You can use the coefficients to kind of make some generalizations about the amounts of things in your equation. We're going to choose to look at the coefficients as mainly moles. If we look at that, then we can make a mole ratio, y'all. We can actually make a lot of different mole ratios. So what I mean by that, like before we get down here to the bottom of the problem, let me use this post-it note. We can write things like this. Is it true that there are like 2 moles of H2? Isn't that what we just said? So I can write it out that way. And for every 2 moles of H2, we said there's 1 mole of O2. That's a true statement based on the equation, 2 to 1. There's 2 moles of H2 for every 2 moles of H2O. That's true based on our equation too, based on those 2's. We could also do that there's 1 mole of O2 for every 2 moles of H2O. What we did when we did mole problems before was anything that we could set equal to each other, didn't we turn them into fractions? We could turn them into coefficients. Not coefficients, what I'm saying. Conversion factors. My brain shot. So this first one, I could rewrite it as 2 moles of H2 over 1 mole of O2. And can't we write all of the equalities the other way? We can flip them. So I could also write 1 mole of O2 over 2 moles of H2. I can write that first statement 2 different ways. Can I do the same thing with the second equality and with the third equality? Yes. Okay. I'm going to pause for a second. So what we're going to do now is we're going to take what we just said and we're going to apply that to a problem. Okay? Alright, these start out just like our previous problems. We start out with the number that we know. So the number that we know is 36, 36.1. Now, last time I really didn't make you write the substance in there. This time it's kind of critical that you do, because we're keeping track of our substances and our substance needs to change. Because my question is about how many moles of oxygen, right? But my info is about water. Do you see that? So another tip for you is how I know that this is going to have one of these mole ratio things in it is because it gives me info about one substance and it asks me about something else. Our previous problems used the same substance the whole way through. So, I start out with 36.1 grams of H2O, and then we do what we've been doing. I make the table, you make the multiplication symbol and a fraction if that's what you want to do. Same way as before, whatever was up top here has to go where? Has to go to the bottom. Well, now look, instead of just putting grams in the bottom, I'm also going to write H2O in the bottom. Got that? So unit and substance. Now, our goal was to get to what? The goal of each problem is to get to moles. So I can go from grams to moles. This is an old problem. How I go from grams to moles was with the molar mass. So remember, I get out my periodic table and I look up the masses and I see that the mass of oxygen is 16 and the mass of hydrogen is 1. Well, there's 2 hydrogens, right? So that's 2 times 1 is 2. Oxygen 16, so 2 plus 16 is 18. Remember, for me, I've asked you to round where? Yeah, we're horrible at this. Ariane, this is your shout out. Where do you round when you pull them off the periodic table? You wanted attention. You're getting it. The 10th. Good job. Thanks, whoever saved her. Who was that? Who was the me? Kenzie did it? It was Miguel. Miguel helped you. Good job, Miguel. All right. What'd I tell you about the word mole up here? What'd I tell you about mole? The number 1 will go with, in every conversion factor except a mole ratio. This is not a mole ratio. If it's a mole ratio, I've got moles on top and moles on the bottom. So it's the same thing we did before. You know everything for 1 mole except the mole ratio. So 1 mole of H2O to 18 grams of H2O. H2O in grams cancels out. My next step is to repeat what we already know. Moles and H2O goes in the bottom. Now, look, now that I'm at mole, mole is my changing of the substance place. Now I can use this new thing called a mole ratio we just learned about. I know it's moles of H2O. Moles of the other thing is going to go on top. What's the question about? Oxygen. Well, look up here. How's it written? O2? Because of Brinkelhoff? So we put moles of O2 to moles of H2O. Where I get these numbers from is the coefficients, like we just came up with on that little post-it note. You know, like we thought through how many moles of one thing to something else. Look up here. How many moles of oxygen? 1. I did put the number 1 with the mole, and that's perfectly acceptable because it's what my equation told me to do. Find H2O. I can't say these. I'm like, I don't know. Blah, blah, blah. How many moles of H2O? 2. Again, I'm getting these numbers from the coefficients in front of those things in the equation. It's 1 mole of O2 for every 2 moles of H2O. Okay? Cancel what you can. Moles and moles cancels. H2O and H2O cancels. If I stop right now, my answer to this question will tell me how many moles of O2 would go with this many grams of H2O. Is that what it asks? How many molecules? Well, you should know from previous experience that you can go from moles of something to molecules of something. And we're doing O2 this time, so moles of O2 to molecules of O2. This was counting. If we go back up for just a second and look at our moleville thing, molecules falls under particles, right? When we counted, the magic number that went with particles was 6.02 times 10 to the 23rd Avogadro's number. So, how do I know where to put the 6.02 number? How do I know that, Ricky? Very good. He said because we know that we always put the number 1 with moles unless it's, he didn't add this, unless it's a mole ratio. And it's not. That was right here. So 1 mole to 6.02 times 10 to the 23rd molecules of O2. Okay? So moles cancels, oxygen cancels. I'm left with molecules of oxygen. Is this where I want to be? Most of you don't have your calculators, and that's perfectly fine. I can go ahead and crunch the numbers for you right now. I get an answer of 6 let's see. How many sig figs can I have? Do you remember what we did before? Yeah. I go back to this number. Nothing else matters. These all have infinite, infinite, infinite. So how many sig figs are here? 3. So my answer can have 3. Here's what my calculator says. Let's see if we can see it. 6.036 blah 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 times 10 to the 23rd. So we're going to cut it off at the 3. So that will become 6.04 times 10 to the 23rd molecules of O2. Now, on your test on this, I could have given it back yesterday, except that, well, I wasn't here to do it. Most of you set up the problems pretty well. Like, if people missed it, a lot of you had the exact setup, but then this was off by decimal places, which leads me to believe it has to be how you're putting it in your calculators. The good news is, if it was a problem like this, when I count it on the test, would you get 1, 2, 3, 4 points out of 5 for having all this stuff set up correctly? So if your calculator's killing you, it's not going to kill your test grade. We do need to get it fixed, though. But some people did, like, part of the problem right and then just kind of quit. Like, you didn't have the rest of the steps. I mean, y'all appeared to know pretty well what you were doing with just simple conversion problems. At this point, I'll work a couple more examples. But here's the deal. I'm not going to work one of everything. Because look, could we go from grams of one substance to particles of another? Or grams to grams? We could go from grams to liters. We could go from grams to moles. And then we could go from liters to grams, and liters to liters, liters to particles, liters to moles. There's like, we could calculate it, but are there a bunch of different ways that this could be worked? I can't work one of everything. There is a general process. And if you know some of these tips right here, things like that the one only goes with, the one goes with everything except for mole ratios, and where you come up with these numbers in the mole ratio from, if you know the general plan, you could do whatever is asked of you. Okay? I'm going to stop this one. So if you're watching it because you're absent today, or you're sitting here with this and you want to watch it again, you could go back and watch the same one again. Okay? And then I'm going to record again in just a minute and do like some more examples without all of the explanation stuff.